Good evening. This is the video for the week 8 MLOps graded assignment. In the objective of week 8 assignment is to introduce data poisoning attacks into the IRIS datasets, evaluate the effect of poisoning levels 0%, 5%, 10%, 50%, analyze how poisoning affect the model uh, performance, accuracy, precision, recall, F1 scores, log all experiments in the MLflow tracking server, and generate and compare the confusion matrices, debug JSON data, and model artifacts. Understand how to mitigate poisoning attacks in real pipelines. So, as we already know, what is data poisoning is just to intentional corruption of the training data and reduce the model accuracy to cause the targeted misclassification. We can introduce this using random noise, label flipping, or outlier insertion. I have uses Gaussian noise injection into the percentage of training samples. Okay, and then this is the training setup in the iris scalar uh, datasets. Use the model random process forest classifiers and use the parsing method of Gaussian noise injection. And MLflow is the track parameter, logs metric, and store the artifacts. And the MLflow server is running at the localhost. As you can see, first I have run my instance and open the SSH in the compute engine, and then I have run the MLflow, first created the vgit folder, as you can see, and then connected my GitHub repo to my vgit folder, and then open the screen, new screen, by the screen command. We have already run many commands and 200 OKU is given. Now we'll detach from this, and then I will show you that I have run the MLflow server and then run the G-Cloud Compute SSH from my laptop to allow the MLflow uh, link to run on my localhost. As you can see, I have accepted it, and here my MLflow is started to run on my local host server, as you can see. Then I have created a file, Python file, in the week 8 folder. By using MLflow debug file, I will print it to show the code. I have created this to poison my data set 0%, 2%, 10%, and 50%. Uh, the goal of my logic, the poison logic in my code is that first I have add random Gaussian nodes to selected sample, and then generate the confusion matrix for each poisoning level, and then I have run the experiment by model training and logging for each poisoning level in the MLflow, and then we have looped through each poisoning fraction to log the runs in the MLflow. So I will now run the code. I have already given the URI for the MLflow tracking. I will now run this file, as I have already run it, as you can see, at 619, but I will run it again. First we have to activate the virtual environment. Run the code. As you can see, the tracking URI is a localhost. Path is deprecated. Please use name instead. Artifact is loaded at the experiment 1 and the experiment 2. 0%, 2%. Now the 10% is loading, and then the 50% is loaded. Now if I reload it, as you can see, the time is updated. Time created is updated, and as you can see, the these are the 43 minutes ago, and these 4 are now the 40 seconds ago. Now I will compare these 4. As I have added the result of these 4 in my GitHub repo in the artifacts folder. You can see the accuracy 0.933, 0.967, 0.933, and the F1 score for each test. As you can see that the accuracy is increased till 10% and then decreased till 50%. It shows that the as you can see, I have written it down here also in my PPT, as this shows that the 0% poisoning is clean decision boundary, minimum misclassification, and 5% poisoning is still clean, small noise and negligible impact. 10% poisoning is the best performing model, confusion matrix almost perfectly diagonal, and the 50% poisoning is more of diagonal values, models start confusing. We can see the confusion matrix in the artifact flat or in the compare. You can see the confusion for each model. This is 0%, as you can see. This is 10%. As you can see, the 10% is almost diagonal, and in 50% more of diagonal value, models start confusing overlapping classes due to heavy noises. So the observation is that the model remains stable under mild poisoning, and moderate poisoning at 10% improve accuracy to noise act like a regularizar. Heavy poisoning began to distort the feature distortion significantly. And the ML flow artifacts confirm that mean and standard deviation shift heavily after poisoning, and confusion matrix become less diagonal at high noise. And I have also added the JSON file. As you can see, to show the stats, mean, standard deviation, shape for each model. This is for the 50%, and this is the mitigation strategies to defense techniques against data poisonings. So first is data validation pipeline, statistical drift detection, robust training methods, data provenance tools as Sarhav teaches us. And the file submitted for week 8 is my code file, week 8 matrix .csv file. As you can see, it is the result file, as I have uploaded it in the GitHub, and the readme 8 week 8 MD markdown file, and the artifact folder which contains confusion matrix PNGs, visual representation of prediction per poisoning level, and debug JSON files which contain poison sample indices before and after feature sticks and metrics per run, which is useful for the auditioning poisoning impact. And there is model artifact to exact model in each run. So I have successfully submitted the data poisoning attacks at 0%, 5%, 10%, and 50%. Logged complete experiments using MLflow, and improved the moderate, improved at moderate noise, and degrade at heavy poisoning I have observed in my data poisoning. So I have also generated a confusion matrix and debug metadata, and learned the data validation, continuous monitoring, artifact tracking, robust model training, and delivered a reproducible and fully tracked MLOps experiment. Thank you. That's all from my side.